Hello, my name is Pavel Krupala from BlenderFreak.com and welcome to another part of Node Editor tutorial series. In this part, this is the final result we are going for. We will implement dragging with the mouse button, so anywhere outside of the elements you can drag around, and we will implement zooming. So with mouse wheel you can zoom underneath your cursor and nothing should break up, so still the window should be resizable, draggable, movable, selectable and everything what we have done so far. So I'm excited, so let's get started. We left off basically somewhere here, and we can, in the graphics view, we can simply override mouse press event function, and the same way we will override mouse release event, and let's call this event, and here we can type if event.button equals to qt middle button, then we can call function self middle mouse button press, and we will pass the event. Otherwise we will call super, which is the parent class, mouse press event, and we will pass the event like this. As in the same way we will do this for the release event. So if event dot button equals to qt middle button, then we will call function middle mouse button release and pass the event. Otherwise we will call the parent function mouse release event, and the parameter will be event. Okay, so now we can type something like define middle mouse button press self and event. We will print pressed and define middle mouse button release self event, and we will print out released. Okay, and when I press play, then you can see in the console pressed, released, which is kinda neat. Dragging still works, so that's awesome. And we are going to do next thing. So basically in the graphics view there is a method which is called setDragMode, and this method can have graphics view dot scroll hand drag. As you can see, if I press middle mouse button, it looks like a hand when I'm starting to scroll, and with the left mouse button now I can drag around the viewport, which basically is the functionality we want. But we want that to be with the middle mouse button, not the left mouse button. So for this we can fake few events. So when we start clicking the middle mouse button, we can create a fake release event, q mouse event, and we can say that this is event of type mouse button release at event local position event dot screen position, and we can say that it was actually the middle mouse button which was released, and then we can pass the buttons and event modifiers which correspond to this event. So for our case this will be Qt, no button, and we will pass the modifiers which came in. So doesn't matter if it was Control, Shift, Alt or whatever other key was pressed or being held during this event. And now we can call the parent class and say mouse release event, release event. So if I press OK, so when I press OK, so it crashed. So let's try left button, and it crashed again. Let's create another event and say fake event will be Q mouse event, event.type, event.localPos, event.screenPos, Qt left button, Qt no event dot buttons or Qt left button. So don't change anything, any other buttons which were pressed, and pass event dot modifier s, and here is probably the bug we had. So let's try it if it fixed that. Yeah, nothing changed because we need to start dragging again. So here was middle button. So let's call this one parent class, call mouse press event and pass in the fake event. Okay, and nothing is happening because we really need to drag with the left mouse button. So let's change this back to left button. So immediately when we click with the middle mouse button, we will fake that the mouse button was released, and we will again fake another event, and we will start the drag mode, and then we will fake that we actually press the left mouse button. So we should be able, after clicking middle mouse button and holding, be already dragging with the viewport. Okay, and when I release the middle mouse button, I'm still dragging the viewport. It doesn't work when you click on some certain elements, so you need to click somewhere outside other Q graphic items which you have already in the scene. So, and when the middle mouse button is released, we will create a new fake event again. This will be Q mouse event again, and the type will be the event type because it is already a release. Then the position when where the event happened, so just localPos and event screenPos, and it will be again the left button, and we will say that the buttons which were pressed were everything what was actually pressed, and we will negate the Qt left button for this, and the modifiers we actually do not care too much, but still we will pass what was there. So self no self, but super. Mouse, release, event, fake event, and self, set drag mode, Q, graphics, view, no, drag. Okay, and now it should be working. Middle mouse button, and I release, everything is changed again. Left, I can select, drag around, awesome. And with clicking with the middle mouse button, I can drag around the canvas or the scene, but not when I'm clicking on Q items. Nice, awesome, so this works. So just for the sake of consistency, I will later use the left button and mouse and right mouse button. So I will quickly type event elif event button was Qt left button, elif event dot button was Qt right button. Then we will call self right mouse button press and pass the event, self right mouse button press event, and the same thing here, elif event dot button equals to Qt left mouse button, then call self left mouse button release, pass the event, elif event dot button equals to Qt right button, self right mouse button release event. Okay, we will jump back down and we will create a define new function which will be left mouse button press self comma event, and when this will be called we will return the parent mouse press event. The same way we will define the release left mouse button release self comma event, and we will return again super mouse release event. So nothing should change yet. Event again for the right mouse button, super mouse press event, and define right mouse button release self event again, turn super dot mouse release event. You should basically could avoid this return function, but if it's not a thread it actually doesn't matter. So the left button does nothing. I click here, select, it works. I can drag around, nothing changed. Middle mouse button works. Okay, so this works. Awesome. And as you can see, still the scroll wheel just slides with the viewport, with the scene, and I really don't like it. I would rather see that a whole canvas will zoom in or zoom out. So the way we can implement this is pretty simple too. We can override this wheel event, and here we can calculate our zoom factor. We will store our mouse position, or better set scene position. We will translate our view, and actually we will also set the scene scale, because there is an awesome function inside the Q widget, Q graphics view, which is called self.scale, and you can pass in the zoom factor or the scale of the graphic view. So by two simple floats you can do all the scaling. But first, what we need is we are going to say here, after setting up the scene, we can say that the zoom in factor will be 1.25 and our current zoom will be 10 and the zoom step will be 1, and we can also try to set up range, so we can clamp the zoom in and zoom out, and we will use a list. So the first item will be the minimum and the second item will be the maximum of our zoom, which we can use. So going back to our wheel event, we can calculate our zoom out factor first. So zoom out factor will be 1 divided by self zoom in factor. It should be enough. So the alt position where actually our event happened, so we need, because we need to center after zooming, and we want to center that exactly on the same spot where our cursor was pointing or our mouse was. So we need to map to scene our event position, which is where the mouse wheel was being dragged up or down, and we will map it to the scene, so we will know the exact coordinates where the center of the mouse was at the moment we start scrolling. So then we can calculate the zoom, which will be quite simple. The zoom factor will be zoom in factor in the case when we are scrolling to zoom in, and we are going to scroll to zoom in when the event angle delta dot y is greater than 0. Also we can calculate with the zoom step, so we can say that self zoom, which we set above earlier, will be plus equal to self dot zoom step. Otherwise, if we were scrolling the other way with the mouse wheel, our zoom factor will be zoom out factor, and the same way we will say self zoom minus equals self zoom step. Another thing, maybe we don't need the clamping, so we can create self zoom clamp is equal to false by default. So by default we won't have any clamping here. So by default our clamping will be off. So in this case, you can just go and say self scale zoom factor, comma zoom factor, and this should scale our scene. So let's try it out. And if I scroll in, it gets zoom in, and if I scroll out, it gets zoom out. So actually I hit the right order of these functions. So the scaling works. Nice. But right now, if my mouse is positioned up here and I zoom in, you can see I'm still scrolling inside here to the middle point where it was. So we can translate our view now by calculating the new position, which will be self, again mapped to scene, event.position, and the delta between these two positions which we have stored, the new position and old position, is exactly the difference we need to translate our current view. So delta.x and delta.y. And if I run the code, and my mouse button will be here, my mouse position is still not working. Why isn't it working? So here we go. I finally figured out why this translate does not actually work, because if I call self translate like 100 and 100 and I press play, as you can see, you are still being in the middle and you are not sliding 100 units anyway. So all of this is not necessary. All of this is not necessary too, but we need to do this simple little thing, and it is we need to set transformation anchor, like written like this, and this is it: q graphics view dot anchor under mouse, because I guess the default is on the center. So now, as you can see, I'm scrolling to the mouse position, which is exactly what we wanted. And I almost forgot to implement the clamping of the zoom, so let's get quickly to it. And the way we can simply do the clamping is we can say clamped false. By default, nothing was clamped. So if self zoom is less than self zoom range, the first limit, then we can say that self zoom and clamped will equal to these values. So the first one will be self zoom range 0. So that's the clamping from of the bottom part, and we will say that clamped was true if self zoom is bigger than self zoom range in the upper range, then self zoom and clamped will be equal to self zoom range 1 and clamped will be true. So we will scale the scene actually only if this was not clamped, like this. And now I can zoom out and no more. I can zoom in and no more. And easily with these settings here you can use zoom clamp. Oh no, you can't yet. If not clamped, or self zoom clamp is false. So now it's false, clamping is off, and if I do zoom clamp to true, you can see the zooming is clamped, the range and the steps are added here. Here is the starting zoom value, so if I put 5 for example here, then I should be at level 5, but still the scene wasn't scaled properly. This starting zoom 5 only means that you are starting in the step 5 between 0 and 10 currently. So I will leave it at 10 because that's adequate to one-to-one zoom, which I use, and I will leave the clamp on. Okay, so this is it. So thank you for watching and see you next time.